Okay, we're in the home stretch here. So we said we had two x-intercepts. They're at -1/2, 0, and 3, 0. Okay, got that. Our y-intercept, so y-intercept, remember how to find this. We set x is equal to 0. So we have y is equal to 2 times 0 plus 1 multiplied by 0 minus 3 squared. Okay, 2 plus, is that plus 1? So 2 times 0 is 0, plus 1 gives me 1. 0 minus 3 is -3, and we square that, we get 9. So my y-intercept is at 0, 9. Okay, that looks good too. Okay, so now let's see what else we need to know. Our maximum number of turning points. So max turning points, and remember how we find this. It's our degree, which was 3, minus 1. So 2 turning points. Because that was 3 minus 1 gave us that. Okay, now we have to put all this together. Oh, we actually need to decide, I skipped something here, whether we cross our touch at each x-intercept. So this x-intercept of -1/2, 0, we need to look at the multiplicity of that factor. That factor just has a degree of 1. Remember, when it's not written, it's degree 1. So that tells us we cross right here. X-intercept of 3, 0, the multiplicity here was 2. So that means we're going to bounce or just touch here. Okay, so this all helps us put this together. So first things first, I've marked off every 2 on here. I'm going to use these as 1. So 1, 2, 3, 4, just to make it a bit easier to see as we do this. So let's start off. We've got an x-intercept at -1/2, 0. So if that's -1, here is -1/2. And we're going to be crossing here. At 3, 0, 1, 2, 3, we're going to bounce. So I just have these x-intercepts drawn in right now. We know our end behavior. As x gets bigger, y gets bigger. So I'm just going to go ahead and put that arrow up in this corner. As x gets smaller, y gets smaller. So down here, the function's going to finish in that direction. What else do we know? We know our y-intercept is at 0, 9. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, kind of ran out of room there. So there's my y-intercept. And we've now got to connect these guys. So at -1/2, 0, we said we cross. So I'm going to come through here, cross. I've got to go through here. I've got to bounce at 3, 0, which means you come down gently and then turn around and go back up. So make that a smooth curve there. That's basically what my function looks like. This is f of x. Do I care how exact it is? No. I want to be able to graph this by hand. So again, it crosses at -1/2, 0. It goes through our y-intercept of 0, 9. And at some point turns around, comes back down. And I do know that it turns around right at 3, 0 because our behavior, because of the multiplicity of 2, says it just touches. It doesn't go across. So it touches and then has to reverse direction. Okay, let's try another one. Last one. Analyze the graph. Okay, it's already in factored form. So first thing I've got to do is find the degree. So let's go ahead and multiply these two things together. So I'm going to have x squared multiplied by x squared minus 3x minus 4. And go ahead and multiply those out using box or FOIL. And now I've got to distribute here. So again, I only care about the first 2 terms multiplied together. That gives me x to the 4th. And then the last 2. There's only 2 here, so it's not that big a deal. Okay, so there's the function. What is my degree? degree equals 4. My leading coefficient is positive. Leading coefficient is positive. That combination tells me my end behavior is going to both go up. As x gets smaller, y gets bigger. As x gets bigger, y gets bigger. So this is kind of like a quadratic, because that's an even one. Number of turning points. Again, since we're talking about degree, let's look at that. Maximum number of turning points is going to be the degree minus 1, so it's 3. It's the most we can have. Okay, x-intercepts now. Again, to find x-intercepts, we set our equation equal to 0. So 0 equals, let's see, how did we do this? 0 equals x squared times x minus 4 times x plus 1. I'm going to solve now for each one of these. So my first x-intercept, I set x squared equal to 0, which gives me x equals 0. The second one is x minus 4 set equal to 0, so x must equal positive 4. And my third factor set equal to 0, I get x equals negative 1. Okay, we need to look at our multiplicities to figure out the behavior here. So x equals 0, the multiplicity was equal to 2, because the exponent is 2. That tells me I touch at that location, or bounce. Again, both words will be used. When x equals 4, let's see, we only have a multiplicity of 1. So multiplicity equals 1. So we cross at this location. X equals negative 1. The multiplicity is 1. So that means we cross there. Excellent. Let's get some y-intercept, or not some, get a y-intercept. When we do this, we replace x with zeros. So we have y equals 0 squared times 0 minus 4 times 0 plus 1. Okay, what does all this give us? 0 times a negative 4 times 1. Well, 0 times anything is 0. So my y-intercept is at 0, 0. Okay, let's start creating our graph. We are just about done. We know our end behavior, so first thing I like to do is go ahead and put those arrows in. We know as x approaches negative infinity, y approaches in positive infinity. And likewise, as x gets bigger, y gets bigger. I've marked off my graph, again, just so that every 2 of these represent 1. So 1, 2, 3, 1, 2, 3. Just gives us a bit more room to see what we're doing. So my first x-intercept is 0, 0. Let's go ahead and put 0, 0 in. And it probably is better to use a different color so they stand out. 0, 0. I have x equals 4. And I have x equals negative 1. Okay. So the first thing I'm going to do, and my y-intercept is 0, 0. Okay, so we know we're crossing there. At x equals negative 1, I have to cross. So that means I'm coming down from here. I cross. And somewhere down here, I've got to turn around and go back up. So I've got to, at x equals 0, I'm going to touch. And I've got to come back down because I'm just bouncing there. And then at x equals 4, I cross. And I should connect with my arrows. One of the reasons I like drawing the arrows in first is that as you go through, you should end up connecting to your arrows correctly. You'll be on the same side of the x-axis. Okay? So again, we drew in our end behavior. We have our x-intercepts and y-intercept. And we know the behavior at each x-intercept. So now we just connect our polynomial, starting with the end behavior. I usually start at the left side. I know at the first x-intercept, I had to cross. So I go across. I have to somehow turn around, come back up, because I bounce here and then cross. And notice the number of turning points, 1, 2, 3, which is exactly what we thought.